What is 5G? Before we explain how 5G works, it's probably a good idea to explain what 5G is. There are a lot of specifics, which we talk about later in this video, but here's a quick primer. 5G is the next generation of mobile broadband that will eventually replace, or at least augment, your 4G LTE connection. With 5G, you'll see exponentially faster download and upload speeds. Latency, or the time it takes devices to communicate with wireless networks, will also drastically decrease. How does 5G work? Now that we know what 5G is, it's a good idea to understand how it works, since it's different from traditional 4G LTE. First, let's talk spectrum. Spectrum. Unlike LTE, 5G operates on 3 different spectrum bands. While this may not seem important, it will have a dramatic effect on your everyday use. Low-band spectrum can also be described as sub-1 GHz spectrum. It's the primary band used by carriers in the US for LTE, and bandwidth is nearly depleted. While low-band spectrum offers great coverage area and wall penetration, there is a big drawback: peak data speeds will top out around 100 megabits per second. T-Mobile is the key player when it comes to low-band spectrum. The carrier picked up a massive amount of 600 MHz spectrum at a Federal Communications Commission (FCC) auction in 2017 and is using it to quickly build out its nationwide 5G network. Mid-band spectrum provides faster speeds and lower latency than low-band. It does, however, fail to penetrate buildings as effectively as low-band spectrum. Expect peak speeds up to 1 gigabit per second on mid-band spectrum. Sprint has the majority of unused mid-band spectrum in the US. The carrier is using Massive MIMO to improve penetration and coverage area on the mid-band. Massive MIMO groups multiple antennas onto a single box, and at a single cell tower, to create multiple simultaneous beams to different users. Sprint will also use beamforming to bolster 5G service on the mid-band. This sends a single focused signal to each and every user in the cell, and systems using it monitor each user to make sure they have a consistent signal. High-band spectrum is what delivers the highest performance for 5G, but with major weaknesses. It is often referred to as wave. High-band spectrum can offer peak speeds up to 10 gigabits per second and has extremely low latency. The main drawback of high-band is that it has low coverage area and building penetration is poor. AT&T, T-Mobile and Verizon are all rolling out high-band spectrum. 5G coverage for the carriers will piggyback off LTE while they work to build out nationwide networks. Since high-band spectrum sacrifices building penetration and coverage area for high speed, it will rely on many small cells. These are low-power base stations that cover small geographic areas and can be combined with beamforming to bolster coverage. How fast is 5G? The International Telecommunication Union (ITU) is a specialized agency at the United Nations that develops technical standards for communication technologies, and it sets the rules for radio spectrum usage and telecommunications interoperability. In 2012, the ITU created a program called IMT for 2020 and beyond. IMT 2020 to research and establish minimum requirements for 5G. After years of work, the agency created a draft report with 13 minimum requirements for 5G in 2017. Please subscribe my YouTube channel, Knowledge by SKNOORZAI, click on bell icon and follow on all social accounts. And let us know in comments on which topic you want us to make video. Once the ITU set the minimum requirements for 5G, the Third Generation Partnership Project 3GPP, a collaboration of telecommunications standards organizations, began work on creating standards for 5G. In December 2017, 3GPP completed its non-standalone (NSA) specifications, and in June 2018 it followed up with its standalone specifications (SAW). Both NSA and SAW standards share the same specifications, but NSA uses existing LTE networks for rollout while SAW will use a next-generation core network. Carriers are starting with the NSA specification, which means you will fall back on 4G LTE in a non-5G environment. The standards set by 3GPP closely correspond with IMT 2020 performance targets and are somewhat complex, but here's a general rundown. Peak data rate – 5G will offer significantly faster data speeds. Peak data rates can hit 20 gigabits per second downlink and 10 gigabits per second uplink per mobile base station. Mind you, that's not the speed you'd experience with 5G unless you have a dedicated connection, it's the speed shared by all users on the cell. Real-world speeds, while the peak data rates for 5G sound pretty impressive, actual speeds won't be the same. The spec calls for user download speeds of 100 megabits per second and upload speeds of 50 megabits per second. Latency, the time it takes data to travel from one point to another, should be at 4 milliseconds in ideal circumstances, and at 1 millisecond for use cases that demand the utmost speed. Think remote surgeries, for instance. Efficiency, radio interfaces should be energy efficient when in use, and drop into low energy mode when not in use. Ideally, a radio should be able to switch into a low energy state within 10 milliseconds when no longer in use. Spectral efficiency is the optimized use of spectrum or bandwidth so that the maximum amount of data can be transmitted with the fewest transmission errors. 5G should have a slightly improved spectral efficiency over LTE, coming in at 30 bits per Hz downlink, and 15 bits per Hz uplink. Mobility, with 5G, base stations should support movement from 0 to 310 miles per hour. This basically means the base station should work across a range of antenna movements, even on a high-speed train. While it's easily done on LTE networks, such mobility can be a challenge on new millimeter wave networks. Connection density, 5G should be able to support many more connected devices than LTE. The standard states 5G should be able to support 1 million connected devices per square kilometer. That's a huge number, which takes into account the slew of devices that will power the Internet of Things (IoT). What can 5G do? Public safety and infrastructure. 5G will allow cities and other municipalities to operate more efficiently. Utility companies will be able to easily track usage remotely, sensors can notify public works departments when drains flood or streetlights go out, and municipalities will be able to quickly and inexpensively install surveillance cameras. Remote device control. Since 5G has remarkably low latency, remote control of heavy machinery will become a reality. While the primary aim is to reduce risk in hazardous environments, it will also allow technicians with specialized skills to control machinery from anywhere in the world. Please subscribe my YouTube channel, Knowledge by SKNOORZAI. Click on bell icon and follow on all social accounts. And let us know in comments on which topic you want us to make video. Where is 5G now? So, when should you expect to see 5G in your neighborhood? Well, it depends on the neighborhood you live in. Some neighborhoods already have 5G access, meaning that all you need to take advantage of the blazingly fast speeds is a 5G-enabled smartphone. All of the major US carriers are working furiously to build out 5G networks, yet deployment across the entire country will nonetheless take several years. If you're interested in seeing if your city has access to 5G, it's also worth noting that each carrier has a different 5G rollout strategy. This means your 5G experience may vary greatly depending on your carrier. Here are all the details we currently have concerning each carrier's deployment plans. What 5G phones are available and should you buy one? Although 5G will undoubtedly change the way we interact with each other and consume media, the change won't happen overnight. It will be a few years before 5G is up and running smoothly across the US. While it's ultimately a personal decision, it may be wise to hold off on buying a 5G handset in 2019. Especially considering the fact that a slew of manufacturers are expected to release 5G-capable handsets in 2020. In addition to the fact that coverage will likely be very spotty, the hardware will also be first-gen. With the exception of a phone AT&T plans to release at the end of 2019. Most of the 5G smartphones that will come in early 2019 will likely have single-band 5G support, rather than hardware that can connect to low, mid, and high-spectrum 5G. Please subscribe my YouTube channel, Knowledge by SKNOORZAI. Click on bell icon and follow on all social accounts. And let us know in comments on which topic you want us to make video.